talk about tangent lines, all right? So a tangent.
Coach,
Yes.
so you give us the test Monday and it'll be due Friday or it'll be due
Yeah,
Wednesday?
it'll be due Friday. All righty. Now, so a tangent line is simply a line that intersects a circle at exactly one point. All right? It's a line that intersects a circle at exactly one point. So what it looks like, fellas, it looks something like this. So there's my circle, right? And there'll be a point on this line. Let me do it in red, right? And that line, it just touches the circle at that one point. So I would say angle, that line L is tangent to circle A at point B, right? So the first thing we got to realize, right? This point B is called a point, the point of tangency, all right? So a line is a tangent if it intersects a circle at exactly one point. So for example, this line here is not a tangent line. Why not? Because it intersects the circle at 2 points, right? Does that make sense? The point where the line intersects the circle is called the point of tangency, okay? Now, sometimes we have what we call common tangents. When we say common, what we mean by that is we mean everywhere. So for example, if I have two circles, right, I can draw a line that's tangent to this circle and at the same time tangent to this circle. So what I would say is line L is a common tangent to circle A and circle B. Now, there's a lot of them, but this is another example of a line that would be called a common tangent. Not a great artist, so you got to deal with me, all right? Does that make sense? Yeah. It just means it's common to two circles. All righty? So when you see the term common tangent, it just means it's common to two circles. Now, sometimes when you take the picture, sometimes it all depends on how that looks based on the circles. So for example, if I have circles that look like this, well, the tangent line is simply that one. That's the tangent, right? It's the tangent there. Now I could have another one here, right? Yeah, I could have another one here, right? So there's a lot of different things that you could see based on what. So make sure you understand what a tangent is, and make sure you can understand that a line might actually be tangent to other ones. All right, so for example, here's an example. How many tangent lines would this have? How many lines do you think you could come up with that could intersect both of those circles at one point? I would go with that one, right? And I would go.
Could you put one right to the center?
Huh?
Could you put one right to the center where both circles intercept?
Well, you tell me. How many times does that cut? That doesn't work. Cuts the circle twice. All right. So that is an example of when you would have two possibilities. What about this? How many possibilities do you see here? How many possible tangents do you see here? What do you think? Yeah,
One.
I would go with one, don't you think? Right here. That's the only place you could get a line that intersects both of those circles. Does that understand? All right, now, so we should know now what a tangent is, and we should have some idea of what a common tangent is. All right, now, if we're talking, what is the shortest distance? What is the shortest distance from a tangent to the center of the circle? All righty. The shortest distance from the tangent to the center of a circle. All right, so let's figure it out. Let's look at a picture. And this is line L, all right? And I tell you line L is a tangent to circle A. If I said to you, find for me the shortest distance from the line to the center, what would you do? Would you draw the radius? Fellas, which line do you think would be the shortest? Red, blue, or green?
Green.
Yeah. The shortest line to the center of the circle is a radius. But here's what's really important. Ready? What's really important is that that radius is perpendicular to the tangent line. All right? That radius is going to be perpendicular. All right, so the tangent line and the radii are going to be perpendicular. That's the shortest distance. Does that make sense? All righty. So let's see what that allows us to do. If we know that the shortest distance to the tangent line from the center of a circle is a radius perpendicular to it, we're going to be able to do all sorts of things. So let's look at the first one I want to show you. I'm going to give you a picture, and this is simply going to be circle J, all right? And then I'm going to give you this. This is point L, and this is point K, right? And then I'm going to draw JL, right? And then I'm going to draw this, right? And I know that JL is perpendicular, right? JL is perpendicular, or I shouldn't say that. I don't know that yet. My bad, my bad, my bad. Right? And I'm going to tell you this is 8. And I'm going to tell you KL equals 15. All righty? And then I'm going to tell you from here to here is 9. If I said to you, right, is that a right triangle? Is triangle JLK, is it right? How would you do that? How would you do that? I want to know if this is a right triangle? What do you know when you have the sides? What do you know when you have the sides? Right triangles.
Yeah.
Pythagorean theorem, right? What's JL?
8.
8. What's KL?
15.
What's KJ?
9.
Really? That's 9.
Oh, my
What's
bad.
K?
18.
Huh? How do you know this side isn't 9? How do you know that this side cannot possibly be 9?
Because it stops at the.
Because it's the hypotenuse.
Yeah.
It's got to be long. So how long is it? Hey, fellas, what is this? What do you call that? What do you call the line segment from the center to a
Or
point?
radius.
Oh, good. So what's this?
Radius.
Oh, what do you know about all radii?
Same.
Yeah. So how far is it from here to here?
17.
17, right? Yes? So I wonder, is 17 squared equal to 8 squared plus 15 squared? What's 17 squared?
289.
289. Is that equal to 64 plus 225? Yes, it is. So what do I know about my little triangle? We know that that is a right triangle. How do you know it's a right triangle? How do you know it's a right triangle? Because what works?
Hypotenuse and then the short and long side are equal
What
to each other.
works? The Pythagorean theorem works. All righty.
Yeah.
Let's try another one. Let's try another one. This one's going to be a little more algebraic, though. This one's going to be a little more algebraic. Use the tangent to find. All right, so here's what I got. I got a circle. And this is called circle G. And I'm going to tell you, this is tangent, right? So GJ, right? And JH. So JH is tangent. I know it doesn't look it, but it's tangent to the circle, right? Now, if I tell you this is 12 and this is 8, and this is X and this is X, how do you know those two? How do you know these two segments are the same? What are they?
Both radiuses.
They're both radii. So since they're both radii, they have to be the same, right? So it's tangent. What's my formula? Well, I know that c squared equals a squared plus b squared. All righty. Well, which side is this? Which side is, yeah, the hypotenuse. Which side is it? GH. Fellas, how long is GH?
8 plus x.
Good. X plus 8 squared. That's this, right? That's this. That equals what? Well, what's this side? X squared. What's this side? 12 squared. Agreed? Look how easy that was. Now, let me get rid of the picture, because now I'm done with the picture. I'm just going to move this up to the top now, right? Let me move this up to the top. So, x plus 8 squared equals x squared plus, what's 12 squared? 144, right? All righty. Anybody can do this really quickly? What's x plus h times x plus 8? X plus 8 times x plus 8. That's what x plus 8 squared is, right? What's x times x? X squared, 8x, 8x, plus 64. What do you do with these two terms? What do you do with those two terms? What do you do with 8x and 8x?
Add them.
Combine them, right?
Yeah.
All righty. So that's what you get after you do the multiplication. Now, we got to get all our x's on one side, right? So look what I'm going to do here. I'm going to subtract x squared here. I'm going to subtract x squared here. So they're gone, right? So now what am I left with? 16x plus 64 equals 144. So I'm going to subtract 64 here, subtract 64 here. Over here, I'm left with what? 16x equals, what's 144 minus 64?
80.
80. And then if I divide both sides by 16, what do I get? X equals 5. The hardest part of that whole problem was understanding that the hypotenuse was x plus 8 squared. Does that make sense? Let me give you one to practice with right now, right? Just going to practice with this one right now. All righty. You're going to have a circle, and this is called circle A. And then I'm going to draw a tangent. That's C. All righty. I'm going to tell you that this is B, point B, right? So here's what I know. AB equals 17. BC equals 14. What's AC? Go. First thing you would do is label your problem correctly. And then all you'd have to do is make sure you made what side the hypotenuse? AB, right? Do you guys all agree with that? Is that what you would have done? Hello. What's 17 squared? What's 14 squared?
196.
What's x squared equal to? What's x squared equal to? 93? What's x?
Root of 93.
Yeah, radical 93, right? Not that big a deal, right?
Nope.
All right, now the last thing you need to know for today, ready? Last thing you need to know for today. If two segments from the same exterior point, right? So you got two segments from the same exterior point. Are tangent to a circle. Then they are congruent. So if you have two segments from some point outside of a circle, and both of those segments are tangent to the circle, then they are congruent. Now, this is what that looks like in a picture, fellas. Here's a circle, we'll call it circle A. Here's a point out here. We'll call that point B, okay? I'm gonna draw a segment. This would be DB. And I'm gonna tell you that DB is tangent to circle A. Then I'm gonna draw another segment, and I'm gonna call it BC. And I'm gonna tell you, now it doesn't look like it, fellas, because I can't draw, but I'm telling you that DB and CB are both tangent to circle A. What this says is those two segments are exactly the same measure. Does that make sense? Yes or no?
Yeah.
All righty. So as long as these two segments are both tangent to the circle and they come from the same exterior point, they will be equal. So now we can do all sorts of problems. So I give you a picture, looks just like the one we just had, right? Right? And I tell you this is x plus 15, and I tell you this is 2x minus 5, and I say to you, what's the value of x? Well, you're given a picture. All you have to do is figure out what's the relationship. I tell you that this is a tangent and this is a tangent. What do you know about these two sides? They have to be congruent. And then I can just solve that. Subtract x from both sides. We get what? X minus 5 equals 15. Add 5 to both sides. Now, fellas, this does not tell me how long the segment is. How long is the segment? How long is each of those segments? Two times 20 minus 5, 35. 20 plus 15, 35. All right? So that's the second thing you got to learn today, right? Second thing you got to learn today, right, is that if you have two segments that are tangent to a circle from the same exterior point, those two segments will be congruent. Does that make sense? Right? Hello? 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 I feel like I'm teaching myself. All right. All righty. Here's a question for you. Here's a question for you. I'm going to give you a circle. Ready? This is circle G. I'm going to draw this line segment. I'm going to call that H. And then I'm going to go, ooh, that's I. And I'm going to tell you this is 40. And this whole thing is 41. And this is 9. Now, if I said to you, is segment HI tangent? Is segment HI, this segment right here, is this segment tangent to circle G? Well, if it is, what do you know? That would be what? Perpendicular, right? Hello?
Yep.
So what would have to be true?
Then GI and HI would have to be congruent to each other. Right?
No, you would just have to see if you have a right triangle.
Never mind.
Because I give you what? I give you all three sides. If this is tangent, it's going to be perpendicular. So I just got to see if I have a right triangle. So 41 squared, does that equal 40 squared plus 9 squared? I don't know. What's 41 squared? What's 41 squared?
1,681.
What's 40 squared?
1,600.
Yeah, 4 times 4 is 16, two zeros. 9 squared, 81. Hey, fellas, is 1681 equal to 1681? Yep. Those can be the sides of a right triangle. So that means HI, this segment right here, is perpendicular, right? And it forms a right triangle. So since it's perpendicular, it's tangent. Does that make sense? Let's try one that isn't, all right? So I'll give you the same picture almost, make it a little different. I tell you, this is 12. This whole thing is 13. And this is 5. I'm sorry, 4. Is this segment right here tangent? Well, if it was, this would be perpendicular. So I wonder if the Pythagorean theorem works. 13 squared, is that equal to 12 squared plus 4 squared? 13 squared. 12 squared. 4 squared. Fellas, what's 144 and 16?
$160.
Those two values are not equal. That's not a right triangle. So this segment is not perpendicular, so it is not a tangent. Does everybody understand that? Hello?
Yes, sir.
All right. If you have a tangent, or you have a segment that might be a tangent, if you draw the radius to the point of tangency, it has to be perpendicular if it's a tangent. But it has to be a radius too, fellas. You understand that? Yes or no?
Yes.
Yes, sir.
All right, so that's the first rule you'll learn today. The second rule you'll learn today was that if you have a point outside a circle and you draw a segment to the circle that's tangent to the circle, and then you draw another one from the same point tangent to the circle, you know that those two segments are congruent. So when you see something that looks like this, 3x minus 6 and x plus 10, well, anytime you're given an algebra problem where you're given variables, all you got to do is figure out the relationship between them. These two segments are equal, so that's all you write. 3x minus 6 equals x plus 10. Now we can get the rest of this out of there, right? And then we can just solve it. So I'm going to subtract x from both sides. 2x minus 6 equals 10. Add 6 to both sides. 2x equals 16. Divide both sides by 2. X equals 8. So if I asked you for x, you would tell me 8. But if I asked you for each side, you would just tell me 18, right? 8 plus 10. All righty. 8 plus 10 is 18. 3 times 8, 24, minus 6, 18. Comprende? Can you guys handle that? Yes, no, maybe?
Yes, sir.
All righty. So let me stop sharing for a second. All righty. Now, I'm gonna put up a worksheet for you to do, just working on those two rules. All right. If you have a line or a line segment that appears to be tangent to a circle, you'll know it's tangent if the radius to the tangent line is perpendicular. All righty? And then the second rule, any segments drawn from the same exterior point that are tangent to the circle are going to be equal. Is that understood? Yes or no?
Sir.
All righty? So you'll only have 6 problems for homework. But here's what you got to start doing now, fellas. Now you got to start getting ready for your test that I'm going to give you after class on Monday, probably during class on Monday. All right? So let's start reviewing that so you can make sure you know what you're talking about. Ready? Let me start sharing my screen again, right? So let's go in order. First thing we talked about was circles and circumference. That's the first thing we talked about. All right? So let's make sure we understand the definitions that you should know. Circle, radius, chord, diameter, right? Those are these, the circle is a curved, it's curved, right? It's unlike all the other things we worked with. These are segments. That's more like what we're used to working with. So first thing we need to understand is we're going to use these things to help us measure these things, okay? So first thing we need to do though, fellas, is understand that there's a relationship between a radius and a diameter. So if I have circle A, and we always name the circle after the center, right? If I draw this line segment right here, I would call that a radius. Why is it a radius? Because the definition of a radius is a line segment whose 2 endpoints are a point that's the center and a point on the circle. Well, how about I go like this? I draw this line segment. Now, if I put those 2 line segments, now these AB is congruent to AC. How come they're congruent? Because they're both radii of the same circle. But what do I get if I put them together? What do you
Diameter.
call, yeah, this is a diameter. What's the definition of diameter? A chord,
Yeah.
a chord that goes through the center of a circle. Well, I just showed you that a radius, right? If I take a radius and multiply it by 2, right here, this and this gives me a diameter. So that's the first thing we learned. A diameter is 2 times the radius. Or if you want, a radius is the diameter over 2. Does that make sense? Comprendes? Not a big deal, right? Not a big deal, I don't think, right? I don't think, right?
Mm-hmm.
All righty. So then the next thing we talked about was this idea of a circumference. What's a circumference? A circumference is simply the distance around a circle. All righty. Now, we have a hard time measuring that because it's not straight. It's not a polygon, it's a curve. So if I asked you, what is the circumference of circle A? What I'd really be asking you was, if you were standing right here and then started walking around a circle, and you walked all the way around the circle until you got back here to point B, what I'd be asking you is, how far did you walk? All right? Well, that's kind of hard to measure using the curve, but it ain't so hard to measure if I use this segment. What segment's this? What do you call this
Radius.
segment? It's the radius, right? And we learned that if you want to find the circumference of a circle, all you got to do is go 2 pi r. So as long as you know the radius, you can find the circumference. So if I told you in this picture that line segment AB was 4 inches, all righty. Well, if I wanted to know the distance around that circle, I would just simply go like this. 2 pi times 4. And 2 times 4 is obviously what? 8 pi, right? And then if I was approximating, I would just take pi. What's pi? 3.14, right? Yes? So I would just take that and go 8 times 3.14. And what would I get?
5.1.
Can't hear you.
25.1. Well, I did exact, so that might not be.
No, that's not exact. Once you take it, once you make it 3.1, so it's 25.
It's 25.1. Yeah.
Point one what?
2.
2. Yes, that's it. That's an approximation, right? And it would be inches, right? So if you started here and walked all the way around and you got back there, you would have walked 25 inches. How's that for you? Now, if I had made that 4 miles, how long would you have walked? You wouldn't have walked 25 inches. You would have walked 25 miles, right? Does that make sense? What if I didn't tell you that? How about I go like this? How about I give you this picture? You have a circle, and that's obviously a diameter, and the diameter is 10 feet. What's the circumference? Well, the circumference is 2 pi r. But we learned earlier that 2r equals d, right? Yeah? So I could just say, well, I know I know that 2 times 5 would be 10, and 2 times r is d. 2 times r is d. I know what d is. So I'm just going to go what? Pi d. So 10 pi. And 10 times 3.14, well, anytime you multiply a decimal by 10, you just move the decimal place what? 1. So it would be 31.4 feet. Does that make sense? So that's one way of using that formula. But fellas, there's another way as well, right? There's another way to use this formula. You can use the formula to find either the radius or the diameter if I give you the circumference. So what if I said to you like this? The circumference of a circle is 36 meters. What's the radius? Well, I would still take my formula, but instead of trying to find C and knowing R, I'm going to try to find R when I know C. So I simply substitute. 36 equals 2 pi R. Now all you got to do is get all you got to do is get R by itself. Divide both sides by 2 pi. Over here, you're left with the radius. And then you just whip out the old calculator. 36. Well, 2 times 3.14 is what? 6.28, right? So if you did that, what do you get? About
56.52.
What is it?
Oh, wait. 36 over 2 pi, you said?
6.28.
Oh, wait. Never mind. That's not right.
36 divided by 6.28.
Okay. 10.03.
What?
You said 36 divided by 6.28?
Yeah.
Oh, whoops. I did 63. Never mind.
What is it?
5.73.
Alrighty. And then, of course, fellas, if you know the radius, do you know the diameter? If you know the radius, do you know the diameter?
Yes.
Yes, you do. Why?
It's just 1/2 the diameter.
Because the radius is 1/2 the diameter. So if you know the diameter, you know the radius. Okay, good. Next thing we talked about, central angles and arcs. Alrighty. And we learned, this will be, I'll just introduce this a little bit, right? A central angle is simply any angle whose vertex is at the center of a circle. That's it. Any angle whose vertex is the center of a circle. And then we learned that if you have a central angle, it cuts your circle into 2 arcs. This arc right here, and this arc right here. This arc would be called the minor arc, and this arc would be called the major arc. And everything is based on a full circle being 360 degrees, right? So if I told you this central angle was 55, what's the measure of the minor arc? Well, it's the same as the central angle that cuts it. But if I asked you what's the measure of the major arc? Well, from here to here is 55 degrees. Well, how would I figure out what the rest of it was? Well, a full circle is what? 360. So I have a full circle of 360. I've already gone 55. How much left do I got to go?
305.
Huh?
305.
305. Very good. Does that make sense, fellas? So central angles, vertexes are at the center of a circle. They have arcs. What kind of central angle is that? What do you call that?
Semicircle.
That's a diameter. So what do you call this arc?
Semicircle.
Yeah.
That's a semicircle. And what's the measure of a semicircle?
180.
180? 180. What's a straight line measure? 180. See how it works? All right, so I'm going to leave it there, fellas. So I will put in a Dropbox a little thing on tangents, just the 2 rules that we did. And then you'll be done for the weekend. Enjoy your weekend. When you come in on Monday, I'll finish reviewing all the stuff we've done with circles, and then you will be given your test that you have the week to do, right? You want to hand it in on Thursday so you can enjoy Friday of Memorial Day weekend, right? It's not that it's going to take you forever. It's just got a few questions on it, right? Does that make sense?
Thank you.
Does everybody follow with that? All right.
Sure.
Not a big deal, all right? All right, so John Garvin, you just sit there on your thing for a
Thank you.
second, all right? All righty, man.
Sure.
Okay, take care, coach.
All right,